Hello and welcome to another video. Today we're going to be doing 71 simplify path. So you're given an absolute path for a Unix style file system which always begins with a slash. Your task is to figure out how to transform this path into its simplified canonical path. Okay, so that makes sense. The rules of a Unix style file system are as follows. A single period represents the current directory. Double period represents the previous slash parent directory. Multiple slashes such as dash slash slash and slash 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 are treated as a single one, and any sequence of periods that does not match the rules above should be treated as a valid directory or file name. Okay, and the path must start with a single slash. The directories within the path must be separated by exactly one slash, and the path must not end with a slash unless it is the root directory. Okay, we're given some examples here. We have home, and we want to remove this trailing slash. For this one, we have home foo, multiple consecutive slashes, we need to replace it with one. And then with this one, a double period makes it go up a directory level. And then you can't go up one level from the root, it's just going to be the root. Okay, this makes sense. And okay, we do know that the path is a valid, like an absolute valid Unix path. Okay, so let's kind of break this down, this problem. We'll set a timer here. Let's take a look at like the specific functionality we need. I think the one thing that jumps out to me right now is we have like a dot dot, and this dot dot means you want to go up a directory. So go up a directory unless the root. There's also another thing that could happen where you have a double slash, so you want this to be treated as a single slash. And then 3, a single period represents the current directory, and path must start with a single slash. I think this is mostly syntaxical stuff, but I think the core logic is just like trying to figure this out. Like trying to figure out like the dot dot part. I think what we can do is we can have a stack, right? We can have some sort of a stack at the beginning, and then we can split everything in this path by the we can split it like with a slash. So we do like path split is equal to like path dot split split, like something like this, right? Where we have path dot split with this mark. I think what's gonna happen is if you split it like this, it's going to be an empty string if you have like a dash and a dash here, right? So if it's an empty string, then you don't want it to actually do anything at that point because you just want it to move forward. So by splitting into a path, these things will be treated as a single slash, or like we can treat it as a single slash by having some sort of logic which removes any empty strings from what we're doing. Now, I think what we can do with this split path, we can go ahead and we can begin iterating through for everything in the path. And then as we iterate through the path, we can begin constructing our basically our path. So our path can start off, let's say like we have something like this. This will be a good example. Home user documents pictures. We append home as we move forward. We append user, we append documents, and then we do a dot dot. And dot dot means that you have to move back a directory, and we can just pop from the stack once we see this encounter. So then we can do pictures at the very end as we append it. Now with this final resulting stack, we can go ahead and append this at the very end. I think what we need to do is we need to append the slash at the beginning because it has to start off with a slash, and then we also have to add along. Yeah, we have to add like every single element in the stack with a slash here. Yeah, stack.join slash home slash slash slash, and then yeah, that makes sense. We have to add it all over, and then yeah, we have to add everything in the stack, and we have to join it together with a slash. Yeah, we have to join it together with the slash. And then at the very end, we also want to keep track of any cases where there's any single periods or double periods. So as we're going through, we want to like negate any things which are empty strings. So stop any empty strings from happening. And then we want to also stop any strings with a dot. And then we can just append that at the very end. So I think this covers all of the cases. Yeah. So I'll begin implementing this out and then seeing how this goes. So we'll have stack split. Actually, we can just copy this. Path split equals path dot split. And then we'll have like a stack which is equal to this. And then for v in path splits, what we're going to want to do is we're going to do if v is equal to a dot or v is equal to nothing, then we know that we want to skip that, so we just want to do continue. Otherwise, if v is equal to a dot dot, then we want to do stack dot pop and then continue. Otherwise, then it's going to be a valid path. Then we want to do a we just pop this. Otherwise, if it's a valid path, then we want to append it to the stack. So stack dot appends to the stack. We want to append the specific string itself. So we want to do a stack or append the value. And at the very end of doing all this, what we can go ahead and do is we can return the slash plus slash dot join, and then we want to join the stack. Okay, let me just actually like go through this again and check to make sure this is valid. This should work for double slashes because this is what will catch it. Should work for periods because we don't want any periods showing up. This is invalid. This is an invalid name. And if triple dot doesn't matter, it's a valid directory. Yeah, this should be good. Let me just quickly run this. Oh. Yeah, let's just walk through this. Stack, path split, for v and path split, if this dot. Yeah. Oh, we wanted this to only happen if there's a stack. So elif stack and v equals dot dot because we only want this to work for if the stack exists. Because you can't go like beyond under the root. Okay. It's working for all of these cases except this one. Path is dot dot slash and we're returning dot dot slash when we're expecting that. Oh, this only needs to happen if the stack is here, because otherwise you still want to remove it from the stack. So we want to do if the stack, then we do stack.pop. Okay. Yeah, this should be good to go. We run this. Nice. The time complexity of this one is going to be O of n because in the worst case, you're going to be storing like every single character in the stack. So that's going to be O of... you're iterating through every single character in the stack. So it's going to be O of n. And you're also splitting it, so it's going to be O of n. And the space complexity is going to be O of n, because at worst case, you're going to be storing everything in the stack as well. Yeah, so... hopefully this explanation made sense to you. Thank you guys for watching.